So I'm going to walk you through a real-life example of how a pressure cooker was created, and this was on a project I was recently involved in, and the wider implications within the major fabrication facility that I worked in. So at the time we had one LTI, and this occurred in February of 2016. As you can see here, we were about 92% complete, which is the red bar, and the blue bars underneath highlight the amount of people we had working on the facility. And this simply shows our forecast to go to sail away. So if you look at this from a bulk construction and a completions point of view, the typical transition 65 to 70% complete, you can see in July of 2015 we significantly ramped up from a resource profile. So this is reflective of the scheduled pressure to complete the job on time. So we had 4 high potential incidents. They're flagged here in yellow. So one was a toolbox explosion from a piece of slag dropping into a toolbox that hadn't been properly stored. Number 2 was an argon purge exposure. The 3rd was a dropped object. 4th was in hydro test preparation, and the LTI occurred at 92% complete. And this was in relation to a hydro test. The reinstatement crew came in to reinstate. There was poor communication, and the large hydro test, around 600 spools, was still in the process of depressuring. So there were a number of factors in the review of why this occurred, but I want to look at this in a slightly different way. So we had a sister project in the same facility. They had one LTI. It happened around 95% complete, and was again in relation to a hydro test. We had the drilling equipment set, which had one high potential incident, which was in relation to a commissioning activity inside a ENI junction box. Within the same facility on other projects, one had gone 600 days without an LTI, 16, 17 million man hours, and then had 4 in very quick succession in the back end. And in my time, in a 2-year time frame in this fabrication yard, there were 3 fatalities. And the point I'm trying to make here, the correlation of where all of these activities occurred were in the last 15% of the projects. So while I don't have all the data associated with the other projects, I want to analyse the LTI that occurred on the project I worked in. So if we look at this, in August of 2015, the black curve here represents our hydro testing curve. So between August and March of 16, when we completed hydro testing, we had to complete 250 tests per month. This was 1,800. All of these would need reinstatement. There was all the heat tracing work, all the insulation scope. And this was part of the reason that we had such an increase in resources. If we applied the process of opportunity and constraint analysis, which you'll see in a previous blog of mine, this orange curve represents have we used the data correctly when all the spools within a given test pack were reported as being installed. So had we gone out, progressively inspected, walked the test pack down, cleared punch items, got them through the QC process, and then tested, if we had allowed, say, a month for this activity to occur, at the point when we ramped up testing in August of 15, we would have had the opportunity to have been 33% further advanced in our hydro testing program. What this would have meant then, instead of 250 tests a month, we only had 171. Would have been fewer reinstatements, less burden on heat trace and insulation, and in my mind this would have led to a much reduced resource peak and would have reduced the scheduled pressure. Ultimately, this leads to the question, would we have seriously hurt this individual? And is there a systemic problem in the industry in the way that we approach the completions process by failing to capitalise on it early enough? And is this actually increasing the safety risk and likely outcome of seriously hurting or killing somebody as projects near completion?